Daily Space Weather Show. And we've got a geomagnetic storm going on, and we've got more space weather on the way. A CME, once again, is directed toward Earth, so that's always a delight. And delighted to bring it to you. So here we go. Let's pick up the pace. Imminent eruption in Grindavik. You see that red area? That is an area where lava could just start flying out of the ground if you're chilling in Grindavik. Don't be in Zone 3. Really, don't be anywhere near there. It's a disaster about to happen. Risk is critical and imminent at Grindavik. Sakurajima, Suino Sejima, Ibu, Luatolo, Samaru, Marapi, Popocatépetl, Fuego Navarro de Ruiz, Sabancaya all erupting as well. Also, we had a 6.7 magnitude earthquake. That's near Macquarie Island. That's where it's located there, deep in the South Pacific. And you may be wondering if it caused a tsunami. Well, it doesn't look like it did. So these are the rest of the earthquakes that have been occurring. 5.4 at the Kermadec Islands there, north of New Zealand. And a 5.1 at Indonesia, a 5.0 near Easter Island, and then a 6.7. Deep in the southern, in the Southern Ocean, really. It's really the Southern Ocean. So not appearing to have caused a tsunami. Also a 5.0 at the mid-Indian Ridge there. And let's move on to more stats. Radio flux is at, I don't know, solar flux units. It's an I don't know. 146 is the radio flux. That is the past year of radio flux, sunspot number, and AP index. Moving right along to our shutting down unnecessary apps and talking about space weather forecasts. Guess what? More space weather on the way to arrive late in the day on the 6th. We'll get to that. It's not on NOAA's forecast yet. It just happened earlier today, so give it a minute. We also have geomagnetic storm conditions at the moment, so check out the high pressure environment at the moment. We also had huge fluctuations in the GOES magnetometers, and we'll get to it. It could be a good night to see the aurora, folks, even at mid-latitudes. So seeing a mild geomagnetic storm condition here, heavy geomagnetic unrest or mild geomagnetic storm conditions have arrived with a CME impact, got a coronal mass ejection. So there is the ground magnetic perturbations map, and check it out. Some big ground magnetic perturbations likely happening there around the South Atlantic anomaly. So if you'd even call those substorms, I don't know, I won't get into it too much, but lots of aurora to be seen. So we may have the aurora here in Pennsylvania tonight. It may be something to check out, especially if you have a high vantage point and clear skies. So one way to see the aurora is by checking out the geoelectric field map. I always like to show that when there's a geomagnetic storm going on, because this shows you actual induction into the power grid. So empirical data there showing you what's going on in terms of induced electricity in the power grid. So again, aurora likely tonight, especially if things keep up the way they've been for the past many hours. Many hours. Now, yesterday, we actually thought it was going to stop raining many hours before it did. So, geez, if I would have been forecasting the weather yesterday, as far as rain times for Pennsylvania, there was some variable that I was missing because I failed. But in any case, we'll get to meteorology stuff in a moment. So, yeah, geomagnetic storm conditions, legit geomagnetic storm conditions at KP 5.67. So, significant geomagnetic storm there. Still mild, but the strongest we've had in quite a while. So, a little uptick in space weather there, and for that, we give a thumbs up. Moving right along to some spacecraft measuring solar wind. So, strongest stuff was right at the beginning here. So it looks like it's a little bit weaker than it was. Strongest conditions were a field of 18 nanotesla with a BZ of negative 15 there. So that's just before it went into the current level. So we'll see what happens there. CME impact began around 9 this morning. 9 this morning, Universal Time, and it continues on, looking like it's a long duration CME impact. So anyway, that's the ACE. Here are the Discover. Discover saw some pretty strong fields too. 16 nanotesla with a BZ of negative 15. By the way, for you new viewers out there, the BZ is the red line up top. That is the vertical component of the magnetic field. Strong negative BZ like this is inducing current, or creating a condition that is more conducive to inducing current in the Earth system. So that is a big factor, a strong negative BZ signal in that top line. We did have some pretty dense solar wind as well, as high as about 50 protons per cubic centimeter there. So some pretty significant stuff showing up. Current conditions are, it looks like it's going back in the negative BZ territory there. So perhaps the aurora are kicking up right now, once again. So again, you can use the maps we showed you earlier, like the geoelectric field map, or the ground magnetic perturbations map is quite good. There is also one that shows you a closer, higher res view of North America. That is the Space Weather Modeling Framework, and we've used it to take auroral imagery here in Pennsylvania. I should show that view so it shows timestamps. There you go. So yeah, and we can't really hang out on here very long because we've got a lot of ground to cover yet. So there's lots of other things to talk about, and let's get to it. Big movements in the GOES magnetometer showed up there around around 1700 Universal Time, which was noon local time for the GOES 16. So yeah, some big magnetic variability happening there. If you want to see a 7-day to put that in context a little bit better for you, there you go, some wild variations happening. Geomagnetic storm conditions, sudden magnetic field changes. Keep in mind they're pretty weak fields. That is nanotesla. Next, our top view ecliptic plane field plot. Earth remains in a south pole oriented magnetic sector. It looks like it's shrinking though, so there could be a rapid sector boundary crossing coming in the next day or two. Here's our line of sight field plot. It shows a lot of information. It's the past 4 days. It shows solar magnetism. Don't know what it means? Ask. Somebody will let you know in the comments. Here's our coronal hole line of sight plot depicting the B field in blue, coronal holes in red for south and green for north. And before we get to sunspots, a brief look at how about 211 angstroms. There you go. And we do have an equatorial coronal hole rotating in here. That's likely to be geoeffective in about 5 days. And it is of south pole orientation, as you can see right there. Moving on to sunspots. Sunspot number is currently at about 105, 103, something like that. And what's next? There's our flare probability monitor and scoreboard, and these sunspots aren't super magnetically complex, so they're not really that likely to produce big flares. I think 3595 is the most likely one, but it's still not really all that likely to produce a large flare. Here are sunspots, the SDO continuum. And one did rapidly form up here, and it's looking promising because it's already producing a ton of carbon. We showed that in the intro. That was the 1600 angstroms wavelength, rapidly forming and active sunspot. So that might be the most likely place to see a large solar flare. It wasn't there, but now it is. Very nice. And before we get to CMEs, that's kind of important. Let's talk proton flux. Proton flux, we ain't got none. It's no SEPs, but they're becoming increasingly likely because we do have some sunspots setting on the western limb. GOES X-ray flux here is kind of down. So, again, sunspot number around 100. It's a little bit of a lull in the action. Don't expect that to continue. Next, a star chart. Actually, let's show some. Oh, yeah, star chart. That's what's next. Sun just set here over Lehigh Valley, Pennsylvania. And goodness graciousness, it was like nearly 70 degrees today. It was just a delight. And next, our solar system forecast. So there are things today. And there are things in 1 week. There we are. New moon falls on the 10th in March. Next, we're going to let this one play all the way through because it's freaking spectacular. A solar eclipse. So I'll just say some things while this plays and talk about some berserk imagery, folks. Look at the pinkness of the solar corona there. Just spectacular. And this is a wake-up call for all of you who are planning on checking out the April 4th solar eclipse, the total solar eclipse. If you're going to buy a telescope, learn how to use it now. Get your solar filters. Get used to tracking the sun. Get used to all of those things that you have to do in order to take imagery like that. I mean, dude, where do you see the prominence up by the North Crown region? It's just fantastic. There's a little bit of prominence stuff. There's a huge prominence. That's probably like 3 Earths tall or something like that. Not half bad. So, yeah. If you're planning on taking some imagery of the sun, if you're planning on investing in a telescope, etc., do that now. I mean, don't wait until like a week before. Have that stuff all tested out so you get a perfect run like that. I mean, that's good times. Now it's gonna toward the end of the video, the sun's gonna reemerge from behind the moon, of course. Some more prominence is popping up there. Good stuff. So if you want to check that out yourself, by the way, that's apod.nasa.gov, the astronomy photo of the day. And if you're wondering what's on my shirt, you can't buy one. It's vintage. It's from like 1992. Check it out. There's a legit hole in it. See that? Yeah. There's a legit hole from skating and carrying boards and crashing. Indeed. And there the sun's coming back out from behind the moon shadow. So it's just, apod.nasa.gov. Check that out yourself. And again, get your solar telescope now, not in April. Get it now. Figure out how to use it. There's still plenty of time. All right, so moving on to CMEs, and we've got some, which are likely earthly directed. So let's go to full screen mode, shall we? Yes, we shall. So you're going to see one coming out of the south, all right? So this is today over on the left. The left imagery is a little bit ahead of the right imagery. And right about 1500, you'll see a CME come out of the south. That has earthly directed components, so they're pretty minor. It's a pretty minor CME period. It's even a little bit hard to tell where it came from, but it came from somewhere in the south, somewhere in the southern hemisphere in the Earth-facing portion of the solar disk. So here's stereo A. You'll see a confirmation of stereo A here. Let's see, about 1500. And, are we missing that data? Oh, that's no good. I think it's missing. Oh, shucks. It stops right before it happens. Does the difference imagery have it, maybe? Nope. Okay, so we got Jonesert on that, but let's, here are our custom images, and you'll see it. Again, right about 1500, you see something happen in the southern hemisphere. And I think it's right down here. I think that's the spot. Let's see. Yeah, it's that spot right there. So that's not even a named filament. I mean, we have multiple named filaments right now. We have this one here, named after Mimi, and then this one right here, which is named after me, by Mimi. So anyway, that Earth-directed CME, or partially Earth-directed CME, came from this area right here. That was a bubble-like looking filament eruption, and part of that is because it's a perspective thing. You know, when there's a CME headed directly toward you, sometimes it looks pretty weird, but that's what happened. And yeah, some massive, massive filaments on the solar disk right now, like this one here, right in the Earth-facing zone, and also this one up here, becoming a prominence here as we produce the video. So that's what's going on. And, oh, that must be the last series of images we have. All right. All right, so let's get to bonus features and blast through this thing. So filaments, like I said, we got massive ones. There you can see them. Those dark absorption features, those are plasma filaments that we have. Wow, we have like a dozen of them on the Earth side of the solar disk. So CME likelihood going forward the next day or two is nearly 100%. You're going to see some CMEs blasting off, most likely. Very high likelihood that some of those could be earthly directed. By the way, if you want to name filaments after living people, do it over on Twitter, x.com/smashomash. Look at the recommendations it gives me. Okay, I can't even scroll them off the screen. Look at this. It just stays there. Ooh, who you might like. Might I? All right, bonus features coming. Bonus features have arrived. That's the past couple of hours, by the way, and look at all the huge prominences all around the eastern and northern portion. We do see flares coming out of this sunspot group already. How's that for a forecast? I guess that counts. Understanding how things work is how you forecast, folks. This is called actual science. What you do is you figure out how the variables relate to reality, and then you watch those variables, and then you forecast reality. That's how science actually works. If there's no predictive value in what you're doing, then what are you doing? Satellite charging hazards are next, and we've got some surface charging type over the Indian Ocean and some more minor surface charging there over the African anomaly and the northern part of the continent. GOES electron flux here has cratered once again, as you get anomalous readings there because of the geomagnetic storm conditions. So these will pop back up, and we're going to have a big increase in the electron flux. So the atmosphere is returning. It's the ionosphere is getting back to its more normal levels of electron flux. As you can see, we've had a very lengthy low electron content, or a low electron flux. Okay, that's the 1 year graph of the electron flux, which is measured at the F layer of the ionosphere. And there's the forecast model that we said wouldn't be right on yesterday's video. We said they'd be off by half an order of magnitude. Well, I didn't say half an order of magnitude, but as you can see, the observation was much higher than the forecast. And we'll see it dip like the forecast shows, but then it's going to come way back up again. So next, the layer where it's measured, the F layer. And here is the data. And here is the anomalygram. There you go. Looks like a geomagnetic storm has been brewing. And it has. So there's lots of red. You get a puffy ionosphere. I'll just leave it at that, because we really got to close this thing out. Here's a global ionosphere nowcast. Yep. That's it. That's a global ionosphere nowcast, or WHAM, the whole atmosphere model. Here's the latest solar imagery. Let's look at this new sunspot as it's been producing a flare while we make the video. It is a beta gamma class, perhaps even beta gamma delta. I think beta gamma, though, for sure. And let's move on to meteorology. By the way, if you enjoyed the music at the beginning of the video, Golden Cat Productions is all over the internet. You can download the tracks from Amazon Music, YouTube Music, iTunes, Spotify, as you can see, and so on. Golden Cat Productions, all over the place. Original music. I started the music label in the year 2000. So here we're looking at sea surface temperatures and currents. So sea surface temperature and current shown there. And frankly, that's like having your pulse. That's like having your pulse on the civilization itself, folks. Because this right here, if this shuts down, well, the northern hemisphere freezes. Basically, is the way that works. So, I mean, if you want to have your finger on the pulse of the quote climate and quote, well, that's a place to do it. As you can see, warm water makes it all the way up to Ireland and Iceland, which the northern hemisphere relies on, acting almost like it's a different planet than the southern hemisphere. So anyway, those are sea surface temperatures and currents for the Atlantic. How about the Southern Ocean? The Indian Ocean? The Pacific Ocean? And there's the Arctic. And here is some meteorology. Jet streams of the east. Surface winds. Surface winds. Jet streams, and so on. Next, clouds and fog. Oh wait, that's visible satellite. That's not clouds and fog. That's visible. Way better. And there is some missing data. Communications breakdowns do happen with satellites. So if you see some glitchiness there are some missing frames. Perhaps some lost packets occurred. Next is our new snow forecast. So this is the Euro model for new snow, and there's still quite a bit to come in the next 3 days. There's a GFS model, the Euro model. So there's the next 12 hours, 24 hours, and 3 days. That is weather.gov. Weather.gov. We do have a bunch of red flag warnings. And let's get to our forecast from Tropical Tidbits. Make sure you follow them on Instagram, etc. Did you know that we have an Instagram as well? Yeah. Anyway, here's our pressure and precipitation forecast for 72 hours, GFS. Some pretty heavy metal weather there on the east part of the country. And snows to taper off, and then more moisture to come to California once again. Yowzers. Next, accumulated positive snow depth change in inches. So California finally simmering down. Here's our total accumulated precipitation in inches, and some very heavy rains there coming to the Gulf Coast. Some areas expected to see 5 inches. 5 inches. Next is our jet stream forecast. The 250 millibar winds. And we have a jet stream divergence, followed by an undulation of the jet stream in the forecast. Next, surface winds and pressure. I figured since we have red flag warnings, we're going to have some pressure gradients, and indeed you do. Not that much wind, though, just dry conditions. Last but not least, temperature anomaly forecast in degrees Celsius. Some extremely warm weather coming to the Mississippi Valley, the Great Lakes region, and then into Canada and New England, while cold weather sticks around in the Northwest. Lightning is next. How about a real-time lightning map? It looks like Florida Shout out to our Floridian viewers. And we do indeed have some strikes there around Palm Coast, as well as Avon Park and Sebring, near the Avon Park Air Force Range, for example. We're closing out with Doppler radar, visible satellite, and water vapor. Here's the recap to close this thing out. Lower 48 Doppler, lower 48 satellite, and lower 48 water vapor. And here's me signing off. And until tomorrow, may that solar wind be at your back. Whoa!